last segment we're going to look at is potable or domestic water heating. Again, we're going to focus on a couple different ways to electrify these systems. Now, most potable water systems are standalone, meaning the HVAC system and the potable system do not overlap. So that's going to be the focus for the next three products. The first one, and most straightforward, is just replacing your gas-fired potable water heater with an equivalent electric water heater. An electric water heater uses an electric element inside the tank to heat the water. The size of these units can get quite large, typically up to 350 MBH of output capacity, and even higher for some custom units. The control is really simple. Most common is just using a temp sensor and a thermostat inside the tank. The plus side of using this type of equipment is cost and ease of replacement. There are, however, a few things to consider. First, you'll need to make sure you have enough electrical power to run the equipment. If you don't, updating the electrical service to accommodate the equipment could get costly. Second, you might need to add more storage capacity in the tank because the recovery rates of the electric heaters are typically slower than gas-fired. This could cause some space constraints if the existing unit is already tucked away in a basement. Lastly, the efficiency of these units will be comparable to gas-fired units. However, most utilities charge more per unit energy of electricity than for gas, so your monthly utility bill will likely be going up. The second option we're showing here is a packaged heat pump water heater. Called packaged because an air source heat pump is integrated into the tank. The heat pump uses the air around the tank as a source of heat and transfers it into a heat exchanger inside the tank. These units are typically smaller in size, with output capacities up to 60 MBH. The advantage of these units over electric resistance is the energy consumption and demand. These heat pumps will be 3 to 4 times more efficient and will help lower your utility bill. There are a few drawbacks to these units though. The first one is cost, which will be noticeably higher than an electric resistance heater. The second is how it operates in the space. Since the heat pump is using the ambient air around the water heater, it's acting like an air conditioner, sending cold air into the space. So there will need to be some design work to make sure this doesn't impact either the occupied space or the operation of the unit itself. This could also be an opportunity for some spaces though. If you have areas that need constant conditioning, there might be a way to utilize the waste cooling as a benefit. The last technology we'll look at here is a split heat pump water heater. As the name implies, the heat pump in this system is not integrated into the hot water storage tank. Rather, it's typically located outside where it can use the ambient air as a heat source. The size of these units range from 2,000 MBH and below. And there are a few advantages of these split units over packaged. First is capacity. Split units can provide much larger heat pumps for larger scale systems. Second, since the split heat pump is outside, it does not have an impact on the indoor ambient air around the storage tank like the packaged unit does. There are a couple things to consider with these units though. First is the ambient conditions. Now that the heat pump is located outside, you'll need to make sure that that unit can operate in the worst case conditions it's going to see. Some manufacturers can provide operation in cold climates down to 0 degrees or even below. The last consideration is the water lines running between the heat pump and the hot water storage tank. If you're located in a cold climate that sees ambient conditions fall below freezing, the designer will need to take precautions to avoid freezing these lines. Heat trace is a common solution to avoid some of those issues. Now, a slight variation of this system would be to use a water source heat pump instead of an air source heat pump. If you have a common water loop, like in a water source heat pump system, tying into that could provide operational advantages for both efficiency and ambient limitations.
Thank you, Charlie and Dan. Remember to download the handouts, which include a bibliography with resources related to electrification. Today we provided a high-level review of electrification of HVAC systems. Look for an Electrification Part 2 in 2021, where we'll dive deeper into the applications. Ask your local Trane office about next year's complete program lineup. And we're currently working on new opportunities and delivery methods to make these programs more effective and accessible to you. Be sure to subscribe to the Trane Engineers Newsletter as well. For those of you seeking continuing education credit, be sure to check out continuing education programs, which include many past E&Ls, all free and on demand. These programs are now located under the self-paced training on Trane.com. Thanks for your time today. We look forward to seeing you next time.